in this video with example and also implementation in C language. In previous video, we already discussed Quicksort one example. Now in this video again we will discuss Quicksort another example and implementation of a Quicksort in C language. These two things we will cover in this video. Let us start with an example. The main logic I already explained in the previous video. So directly here I am going to the properties, everything are you can see in the previous video. So the main technique involved in Quicksort technique is divide and conquer. Divide and conquer technique. Let us start with an example. So now for example the elements are 10, 8, 6, 3, 14, 32, 16. These are the elements. Now we want to sort these elements by using Quicksort technique. How can we sort? First take the array. If we represent like this, it is easy to represent the positions. That's why I am representing all these elements in the form of an array. 10, 8, 6, 3, 14, 32, 16. 0, 1, 2, 3, 4, 5, 6. These are the elements. As you know, we are considering first element as the pivot element. This is a pivot element position which is nothing but a 0 and I is present here and j is present here. Now what we will do first? First we will compare A of I and the pivot element. These two we will compare first. Okay. So if A of I is less than or equal to A of pivot, then we will increment I. That means here I will be incremented, j will be decremented. I will be incremented, j will be decremented. Okay. If this is satisfied, then I will be incremented. Now another one is if A of j is greater than A of pivot, then j minus minus. J will be decremented. That means j is moving towards left direction. Okay, I is moving towards a forward direction. J is moving towards left direction. Okay. So now remember these two conditions. Okay. So I will be incremented and j will be decremented. Somewhere I incrementation will be stopped. Somewhere j decrementation will be stopped. Okay. So then check the positions of I and j. Somewhere I will be stopped, j will be stopped. Then check the positions of I and j. So if I is less than j, swap A of I and A of j. Otherwise, swap else. Otherwise, swap A of j and pivot element. So if you remember this, if you understand this concept, the Quicksort, you can solve the problem and you can write the program. Okay, this is very important to sort the elements using Quicksort technique. Okay, now let us start example. Now step 1, compare A of I and pivot element. That means both are same, na? No need. So the A of I, what is A of I? 10 and 10. So 10 is less than or equal to 10. Then what will happen? I will be incremented. So I will be incremented. Next, 8 is less than or equal to 10. 8 less than or equal to 10 only, na? See the condition what here we are checking. Okay, I will be incremented. So I will come to this position. again 6 less than or equal to 10, then this condition is also satisfied. So I will be incremented. Next, 3 is less than or equal to 10. So then also I will be incremented. Okay, 14 less than or equal to 10. Condition is failed. So I incrementation will be stopped. I mentioned here somewhere I incrementation will be stopped. See here I incrementation is stopped. 14 less than or equal to 10. Condition is failed. Okay. So now coming to whenever I incrementation is stopped, then we are coming to J position. So what is the condition we are checking here? A of J is greater than A of pivot element, then decrement J. So now what will happen here? Now what is A of J? A of J means 16. 16 is greater than 10. Then J will be decremented. Yes, 16 is greater than 10. J will be decremented. Next, what is Jth position element? 32. So 32 is greater than pivot element is 10. Again J will be decremented. Now J will be decremented. Now again what happened? Next position 14. 14 greater than 10. Yes, condition is satisfied. Then again J decrement. Decrement J. Now here what happened? 3 greater than 10. Condition is failed. Here I mentioned J decrementation somewhere. It will be stopped. Okay. So that's why what shall we do? Check the positions of I and J. Now, I is stopped here. If you observe, I is stopped here, J is stopped here. And I is not less than J. See, I position here it is. I position is 4. J position is 3. I is not less than 3. I is not less than 3 or J. So what shall we do? Swap A of J and pivot element. So which two we have to swap? See, this one we have to swap A of J and this one we have to swap. Okay, now the array elements are, see here I am writing. So now the array elements are, so first element, so 3 is coming to this position. So 3, 8, 6 as it is, in this place 10 you will get 14, 32, 16. So now see, if you observe, 10 is the pivot element. This is left sub array. This is right sub array. Okay. Now coming to second iteration. In the second iteration, now I am writing that modified array, this one, this 3, 8, 6, 10, 14, 32, 16. 0, 1, 2, 3, 4, 5, 6. Okay. So here it is J position now. So now this is I, this is J. Sorry, this is left sub array. This is left sub array and this is right sub array. What shall we do now? This pivot element, the property here we have to observe is pivot element means this one. 10. Pivot element divided array into 2 sub-arrays. 2 sub-arrays like left sub-array and another one is right sub-array. Like that, the pivot element is divided. So now What shall we do now? Consider left sub array 3, 8, 6. First, we will apply the same quicksort technique on this left subarray. Next, consider right subarray, that is 14, 32, 16. Okay. Now, let us start with left subarray. The same process, ma. So the same, whatever previously we discussed, the same process we will apply for left subarray. Okay, that means now this is pivot element, this is I, first position we are considering as pivot element, and this is J. So as usual in step 3, first point, that means step 3.1, assume it as 3.1. 3 less than or equal to 3, then I incrementation. 8 less than or equal to 3. See, A of I, 8 less than or equal to 3. Condition is fit. So, I stops here. I stops here. Then what shall we do? Move on to J. Now, check here. Is 6 greater than 3? Yes. Then, decrement J. Next, is 8 greater than 3? Yes. Decrement J. Now, both are same. Condition will fail. So, now, A of J. Now, I incrementation stopped. I, J. Both are stopped here. Both are stopped here. Then, what we have to do? Check I and J positions. This is 0, 1, 2. So, I position is 1. J position is 0. I less than J condition failed. So then what we have to swap? So swap A of J and A of pivot element. Swap these two. But here what happened? Both are present in the same position. So there is no left subarray. Now consider right subarray. Right subarray 8, 6. Now we have to consider. Okay. So now consider 8, 6. Step 3.2. Consider 8, 6. First element as pivot element. This is I and this is J. Compare 8 less than or equal to 8. Condition is satisfied. I is incremented. 6 less than or equal to 8. Condition is satisfied. Increment I. Now increments I. See what are the positions of 8 and 6? 8 and 6 positions here are, observe, 8 and 6 positions are 1 and 2. The same positions here we have to write. See, whenever you are writing this subarray, again don't start from 0 onwards. Why? Because this is subarray you got from this array. In this array, what is the position of this 8? 1. What is the position of 6? 2. So that's why these positions only you have to write. Remember, most of the students will mistake here only. They will start from 0 and 1. Don't do like that. Okay. Now, 6 less than or equal to, now it is a stop, but na I crosses J. So now swap what? A of J and pivot element. What is A of J? 6. Pivot element is 8. Swap A of J and A of pivot. Now what will happen? Here you will get 6 and here you will get 8. And now after swapping, what happened? These two are in proper order. So or otherwise this is pivot element. Na? Pivot element divides array into 2 subarrays. Na? This is left subarray, only one element is there. There is no right subarray. Leave that. So 6, 8 as it is. Now if you consider this array, the elements are 6, 8. But this subarray you got from which one? This subarray we got from this 3. Left side 3 will present. So, from here we will represent 3, 6, 8. Left subarray. Now see, here, if you considered this array, now we got 3, 6 and 8. Okay. Now consider right subarray. Same process. See the positions of 14, 32, 16. This right subarray positions. So 0, 1, 2, 3, 4, 5, 6. So here it is 4, 5, 6. Write those positions. Remember, students, here again we will not start from 0. Here we will start. What is the position here? 4. The same position here we will write. Okay. Now, this is I and this is pivot element. This is J position. Now start our quicksort logic. So 14 less than or equal to 14, I incrementation. Next 32 less than or equal to 14, condition is failed. So I stops here. Coming to J, 16 greater than 14, yes, satisfied, decrement J. 32 greater than 14, this is decrement J, and this is also satisfied, decrement J. Now decrement J. Next 14 greater than 14, condition is failed. So J stops here. I stopped, J stopped. Check the condition. Is I less than J? No. Then what you have to swap? Swap A of J and pivot element. If you observe, A of J and pivot are present in the same position. So here there is no left subarray. Consider only right subarray 32 and 16. Now consider and observe the positions. 32 and 16 are present in 5, 6 positions. 32 and 16. 32 and 16. This is 5th position, this is 6th position, this is pivot position, this is I, and this is J. As usual, 32 less than or equal to 32, I will be incremented, I incrementation. 16 less than or equal to 32, I incrementation, I plus plus. But out of an array, then what shall we do? Coming to J position. J position 16 greater than 32, condition is failed. Okay, then. So that means J also stopped here. Then what we have to do? Check the positions of I and J. See, J position is 6. I is out of an array. That means I crosses J. Then what we have to swap? Swap A of J and pivot element. If you swap, then you will get 16, 32. This you got from 1632. See, before that 14 is present. Now here we will represent 14. From this subarray 3, 6, 8. From this subarray 14, 16, 32. So finally the sorted array is 3, 6, 8, 14, 16, 32. From this subarray. But if you observe here, 10 is there. 10 pivot element. If you observe, see. Yeah. This is left subarray. This is right subarray. In between that, 10 is there. So, we will represent that 10 now. So the array is 3, 6, 8, 10, 14, 16, 32. This is your sorted array. Okay. Students, solve another example. If you have any doubt, you post your problem or where you are not getting, you can post in comment box. Take this as another example to practice. Solve it and tell me whether can you able to solve the problem or not. Say yes or no after solving this. Okay. Take another example like 18, 13, 12, 20, 32, 19, 14. So apply Quicksort technique to sort the elements. So now, example completed, students. Now we will implement this Quicksort in C language. Now how can you implement? Now we will open Turbo C++ editor. This is Turbo C++ editor. Now open a new file, new full screen F5. Now implementation of Quicksort technique. Implementation of Quicksort technique. Okay. Include the header files. Hash include std io.h, then hash include conio.h. Start your main function. Start your main function. Now to sort the elements, the variables required here are: one is array variable, then array size, and I for loop control variable. Clear screen. Now, so first array size we will read now. Read array size. Hope you understand that. Whenever you are working with arrays, first we have to read the array size. So printf enter array size. Scanf %d address of array size n. Now after reading array size, that means some 5 elements, 10 elements, like that, after reading we have to read what are those elements. So read elements into the array. So first we will write printf enter elements into the array. Reading one-dimensional array requires one loop. So I am writing the loop I equal to 0, I less than n, I plus plus, then scanf %d address of I. Reading the array elements is completed. So now we have to sort the array. So sort the array by using Quicksort function array lowest index. Now here left side index and right side indexes are important. So that's why a comma 0 comma n minus 1. So everything will be done in Quicksort function. In this function, so sort will be done. In this function, sort will be done. After sorting, print the sorted array. So printf new line, the sorted array is /n. In the new line, the elements will be printed. So /n I have given. Printing the array means loop is required. So for I equal to 0, I less than n, I plus plus, printf %d /t double quotes close comma a of I, get ch. Now main function is close. Quick underscore sort dot c. The file name is changed. See, file name is changed here. Previously no name is there. Now whenever I saved, then you will get that file name. Now this function here, this is called function call. This is function call. Now we have to define the function. So how to define the function? Now void function name quick underscore sort of integer n. Okay. Now local variables, local to this function, the variables I is required na. Left side I we have taken. See the example what we have solved. I is present in left side, j is present on right side. Then pivot, we will take first starting element as the pivot element. For swap, so temporary variable is required and the low variable and the high variable are required. So now what is low and high? Low is present in here, low and high. See here, low and high, here we will take, this is 0 low position, this is high n minus 1. Here we will take, instead of taking that local, this is low and high. If we declare like that na, then no need here temp. So low is nothing but, so here 0 is nothing but low, n minus 1 is nothing but high. Initialize I and j. I is present left side, j is present on last position, so high position. We are considering pivot is the first position, so low. So what is our assumption? First element as the pivot element. First element as the pivot element. Now see here we had to consider the array. Low is less than high only. We have to repeat all this process. So that's why low less than high. And I is always left side. J is present on right hand side. And that will be repeated. Not a single time. It has to repeat. So that's why while I less than J. Now we have checked the condition na. See here. All these conditions we have written. See this logic we will write now. This logic. So this entire logic we will write now. This one. Okay. This one we will write now. Okay. So now for that, coming to our editor, press Alt Enter to maximize the screen. Yeah. Save it. So while I less than J, we are comparing while of I less than or equal to pivot element, then increment I. If I stops, then compare A of J and A of pivot. Students, if you have any confusion in writing this, we have solved the example and we have written logic na. You write on paper and keep beside of your system. Then execute this program by seeing that solution and this program. Then it is easy to understand. Okay. So now after this, J should be decremented. So now I incrementation stops somewhere, J decrementation stops. Now what shall we do? We have to check what is the position of I and J. If I is less than j, if I is less than j, then we have to swap. We have to swap a of I and a of j. You know swap logic. Temp equal to a of I equal to a of j equal to temp. Okay, this, if is close, then close this while loop is closed. Now whenever this condition is failed, that means it is not I less than j, then what we are swapping? Swap, I am writing in comments, swap a of j and a of pivot. Then how to write the logic for that? Temp equal to a of j equal to a of pivot, then a of pivot equal to temp. Like that we swap. Then what will happen? So here array is divided into two parts. Array is divided into two sub arrays. So you have to sort those sub arrays. So I'm taking the function Quicksort of a comma, three parameters we have passed here. If you observe, see a comma, in that array what is the low position, what is the high position. This is entire array. Now we are considering left sub array. Left sub array lowest index is low only, highest index is j minus 1. Why? Because jth position is the pivot element position. Now quick underscore sort of a comma j plus 1 comma high. Okay, so recursive call for left subarray. That means the same process repeat for left subarray, same process repeat for right subarray. Okay, now close that if and close your function, save your program, compile. If any errors, then we can rectify. See, function call missing parenthesis. That means we missed parenthesis. See, go to that line and put parenthesis, save your program. Now compile. Still one more error. Type mismatch in redeclaration of a quicksort. Remember, whenever you are getting this type of error, you missed function declaration. So select this. Go to edit option. Copy. Here you have to paste. Alt E. Paste and then semicolon. Save. Compile. Execute. Array size 5, 12, 4, 67, 32, 22. See, 4, 12, 22, 32, 67. This is the sorted array. This is the program for Quicksort technique in C language. Hope you understand, students. If you have any doubt in problem solving or the program, so you please comment me in the comment box. So hope you understand. Okay, students, take care. Bye bye. If you like this video, please share this video to your friends and subscribe the channel to get latest videos. Thank you. Bye. Have a great day.